What's up, guys? Welcome back to Vanover Machine and Repair, and welcome back to a very exciting video. For the first time in my entire life, we have a brand new machine behind me, and I want to invite you guys on a journey as we get this thing uncrated and talk about why we bought this machine. But first, we have some things we need to discuss. First of all, this video is going to have a ton of talking, and if that's not your thing, no worries. We have lots of machining content to come. I'm extremely passionate about machines and especially lathes, and because this is a big day for me, I want to bring those of you who care along for the ride. The first question I'm going to get is, what happened to the old Lion Lathe? Great news, we're keeping the machine. But I came to a conclusion that I couldn't get that machine done in a reasonable amount of time without severely compromising the way that that machine was being done. So we went out and bought a brand new lathe, and that lathe is going to be the backbone of our shop. Once we get the boring mill done, we'll come back to that project and we'll do it the exact right way and the way that I want to do it, and it's going to be great. But until then, we have this new machine so we can get work done and start generating revenue. Now, in regards to a Lion Lathe specifically, it's my goal to be as honest with you guys as possible. Johnny is the representative at International Machine that sells Lion Lathes, and he does not know that I'm making this video. There is no deal between him and me about what I'm gonna say about this machine particularly. But I am gonna tell you the good things and the bad things that I find, so that way if any of you guys are curious about buying a Lion Lathe, then you know what you're getting in for. And for those of you that aren't gonna be buying a Lion Lathe, this is a great opportunity to see some of the features of newer machines and see it compared to some of the older equipment and see, are new machines really that great, or is old iron really the way to go? So with all that out of the way, we're gonna jump right over to the machine and start getting it uncrated and see how it goes. I will say that this machine is crated extremely well. Came all the way from California to Chicago, and it looks to be undamaged. Here we go. Here's the unveil. In terms of the packaging of the machine, I would say it's excellent. Now, if you've ever bought a machine brand new, or any machine for that matter, the packaging is important. A lot of times you buy equipment and it's not what you thought, or you buy it and it shows up damaged. These guys went above and beyond to ship this thing over 2 days to get it here. This pallet is tongue and groove. It's very thick, and even the riggers complimented on how well this thing was packaged. All these chucks and accessories are tied down with strapping and screws. This thing wasn't moving or getting damaged at all. This machine is heavily cosmolined, and what I really like is the team went and spent extra time putting labels everywhere on the machine. Support to be used at all times. Remove this safety guard and remove the cosmoline. Loosen this lever before use. That's stuff that they don't have to do, but they take the time so that way the end user has a good experience. And overall, I'm very happy with how this machine came. There's no damage and everything looks great. The first thing I'm gonna do is I'm gonna get some of this stuff off the bottom of the pallet, and we're gonna see if we can get this thing on the ground. Now, I was gonna have the riggers do that, but I opted to do it myself. I think it's gonna be rather simple and straightforward. So we'll get the bottom cleared out, and then we'll lift up either end and we'll get it set on the ground. Look at this little baby coolant pump. Got a face plate here. Nice 4-jaw chuck here. With all the stuff removed underneath, it's time to take this off the base. So they've gone ahead and bolted this down to the pallet every jacking point. So we need to come around and just remove all these nuts and take the studs out so we can separate the pallet from the base of the machine. All right, let's get these bolts off here. Not too bad. We just need to do that 10 more times. Now that all the bolts are removed, let's get this thing off the pallet. I know some of you guys are going to disagree with this, but I think this is the safest, quickest, easiest way to do this. So this lathe has 2 lifting points. There's holes in the casting there and holes in the casting in the back. I've already gone ahead and put a bar through on the front, and we're going to put one on the back. The goal is to come in here with the forklift, lift up here, and then set the actual lathe down on these 2 jack stands, which will support the bar. Should be nice and stable. We'll take the forklift, bring it around to the back, lift up on the lathe, and keep the forklift on. And then because we have a second forklift, I've already rigged up a strap to the pallet and ensured that the pallet is free. And then we'll just pull the pallet straight out from under it, let down the back, and then come around to the front and let down the front. This is where it would definitely be nicer to have my longer forks, but I don't have them yet, so we're gonna give this a shot, see how we do. Well, we got touchdown. It's not on the floor yet, but I need to make some leveling feet. It came with leveling pads, but with my other machines and me being a little bit taller, I think I'm gonna spend the time and make some taller leveling pads. It'll also distribute the load on the concrete a little bit better. But overall, I think that went pretty dang smooth. I'm one person. My wife was here earlier. She offered to stay, but I told her I had it. And yeah, 20, 25 minutes maybe. And we got that off the pallet, I think rather safely and efficiently. We had one minor casualty. We had a bolt that was bent on the back rear cover, super superficial, and I just barely kissed the paint here with the forks. This would have been probably 100% golden if you had just a little bit taller jack stands and if I had the longer forks, which I don't have yet. Otherwise, I think that worked out pretty dang well. So what I'm gonna do next is I'm gonna get it in place. I'm just gonna kind of dolly it back, super easy now that we have it on the skates. And we'll get it roughly where I think it's gonna go, and we're gonna park it there for the night. and I need to make a list of some stuff that I'm gonna do to this machine before we put it into service, and we'll go over that. Before we move this guy back into position, let's talk specs of the machine in case anyone is not familiar. So what we bought here is a 25-inch swing. It has 17 inches over the cross slide. If you remove the gap, it has 31.5 inches of swing. And this lathe here is 120 inches between centers. And for me, I have a shorter lathe, and I really didn't want to buy anything shorter than this. It seems a little overkill on the length for most people, but when it comes to length, it's better to have it and not need it than to need it and not have it. And frankly, I would have got a longer one, but I kind of rarely will use this length, and with the large spindle bore, I think this will allow me to do a lot more jobs that I couldn't do without having to give up the space commitment for something like double this length. In terms of the spindle nose, it is a D111. It has a 4 1/8 roughly spindle bore, so a nice large spindle bore. It has a triple stack SKF bearing arrangement in the headstock. So SKF is one of the top tier brands, and a lot of lathes use a double arrangement, a tapered bearing on the front, and sometimes a tapered and or roller on the back. This actually uses a double bearing on the front and then a back support bearing as well. As far as the threads this will cut, it'll cut all the way down to 2 TPI, so fairly aggressive. It does metric and standard threading without change gears, just a flip of the switch. Has a maximum taper turning length of 15 3/4, and it has a 5 Morris taper tailstock. The quill has 8.5 inches of travel, and it is a 2-speed tailstock, which is really, really exciting. And the motor is a 15 horsepower motor. We currently have it wired up for 440 volt, although it can be wired for 220 3-phase as well. And overall weight of this machine as configured is 9,600 pounds. So those are just the general specs. It does have coolant set up as well and a 4-way power rapid traverse. But I wanted to just kind of give a general overview in case you guys are not aware of the class and just general specs of the machine. Now we get into some nitty-gritty details. I want to talk about my initial impressions, sharing some things I like and things I don't like without using the machine, just as it sits unloaded, looking at it, looking at the design, and give you my initial thoughts. So we're going to start out with the things I like so far. Now obviously I like the 4-inch spindle bore and the metric threading and the big swing, but these are some things that may not initially jump out. So the first thing is coolant. Guys, I know you know how big of a deal this is because I've been running no coolant for a long time, and part of the reason we didn't add coolant to that machine is I knew I was getting this machine, and we're gonna keep that machine set up old school, no coolant, no mess, and this machine will have coolant. And the reason that's nice is because it has all the protections, so it'll contain the coolant properly. 4-way rapid traverse, so that's unique to this machine or any of the Lion lathes. You can pull on this lever up or down, side to side, and it engages your feeds, which is really nice, all from one lever. Most lathes have 2 different levers, and then in that feed, so like forward, you can hit the green button and it'll rapid traverse. It's really, really slick feature that's present pretty much only on the Lions. Some Summit lathes have them and a couple other manufacturers, but most of the newer machines do not have a joystick style, or I would say, you know, I don't know, maybe 30% have them, so that's a really, really nice feature. The other thing I really like on this is it has a bang-in electrical cabinet. Now I know this is probably not a big deal to most people, but I've been working on old machines for a long time, and the electrical is always a disaster. I opened up that cabinet, it is clean, the wires are labeled, everything is done nice and professional, and to me, it just makes me feel good. The other thing I really like that no one cares about is this carriage actually has two lands where we mount this follow rest. That's a very rigid way to mount a follow rest. A lot of lathes actually tie in down lower, and the really nice part about that is we're going to be doing something custom on this lathe. And the fact that we have some nice mounting places up here that's rigid and part of the casting of the apron slash carriage is really, really nice. It allows some customization options and gives us some good rigidity. So that's cool to see. I didn't know how that was going to turn out, but now that I see it, I'm really happy that we have some mounting holes for some aftermarket stuff. So that's kind of cool. We have the Newall DP700. So aside from Stefano's DRO, which is pretty awesome, this is my next favorite DRO on the market. And Newall is now making their stuff back in the UK. And so the Newall products are great. The other nice thing about this is they have a 5-year warranty on all the encoders. The normal Newall stuff is a 1-3, I think. But when you step up to the bigger one, you get a 5-year on everything. And the encoders are supposed to be slightly higher quality. So that's really, really nice. The other thing I really, really like is this machine has a 2-speed tailstock. If you guys seen my other video with the Lion, we actually made our own 2-speed tailstock, which is kind of crazy. But this machine, 2-speed tailstock, is really, really nice. Honestly, it puts mine to shame. This shifts a little bit smoother. It's a shorter throw, and it's going to be sweet to be able to get more torque or more speed out of the tailstock, which is really, really trick. The other thing that's on the tailstock that I really like is it has a quick lock feature, and it's kind of dumb. Most lathes have it, but the reason I like it is because my pacemaker doesn't have it. So I'm not used to something that I can just disengage and move. I've got like 4 bolts that I got to tighten down, so that is super trick that I can just basically pull this up to lock it, pull it down, and move the tailstock nice and quick. So I'm really excited about that. The other thing is it has a chip guard for the lead screw. It's the little things, guys, and it's really nice to see that this lead screw is covered. Not unique to Lion. A lot of these guys do it, not all of them, but it's cool to see that it is covered up, so that keeps the chips out of the lead screw, and it's just a nice touch as well. And then something else that's really kind of near and dear to me, but probably no one else cares about, is all the labels on this machine are really nice. They're very nice and legible. There's a lot of good quality into them, and you can tell that they took some time and did a good job. On a lot of machines, that's where you skip because it's not really necessary. But as someone who's restored multiple machines, I've spent good money for labels, thousands of dollars actually, and to see these done right and done well, it's just little details that really make a big difference to me. Now that we got into some good stuff that just jumps out at me initially, let's get into some things I don't like, because no machine is perfect. And I'm going to be picky on this machine because I paid a ton of money for it, and also I'm restoring a similar version of this machine in a little bit bigger class. I know how this machine is put together because it's very similar to my other Lion lathe, and so I can be picky. And if Johnny's watching this, I would just take this as feedback. Nothing's ever going to be perfect, and everyone sort of has their own things that they like and dislike. So let me get into it. So the first thing that kind of bothers me about this lathe is the paintwork is not that great. From the video, you guys probably can't tell, and guys, this doesn't matter at all. It really doesn't. But as someone who's done some pretty bang-on paint jobs and some not so great paint jobs, for what you pay for the machine, they probably do B- on paint, maybe C+. The body work on the front is significantly better, but on the back and in some hard to reach areas, it's really not up to what I would do when I rebuild a machine. And obviously when we rebuild our Lion, we're currently in the body work stage and we're doing a better job than they did. So That's just a fact. Now I know that body work takes a lot of time and it doesn't matter, and that's true because it's just gonna get dinged and dented. But I'm particular about my machines, and there are spots on the machine where you can tell it looks like they sprayed it, and then other spots where they rolled it and they kind of bounce back and forth. Honestly, to do a machine right and take everything apart and spray it individually probably doesn't make any financial sense. So I see why they cut corners where they can, and practically it makes no difference. But that's probably my biggest gripe, is where it sort of doesn't matter. The fit and finish on certain things is kind of iffy. Now, when it comes to the stuff that does matter, the ways, the steady rest, the setup, fit and finish is top notch. But a lot of the superfluous stuff that I'm OCD about is kind of where they skipped out a little bit, in my opinion, just compared to some other machines. Obviously, compared to anything else that you're gonna buy these days, I think the quality is very good. But I have seen some other machines, most of them older, that had a higher level of finishing than this machine. So I'll say that. The other thing that I noticed right from the get-go is there was no crank on this tailstock. Now this tailstock is probably on the large side for a small tailstock, meaning that it's not a big tailstock that has a crank, but it's also not a small tailstock. And looking at the size of it, I don't know, my other tailstock's about 600 pounds. This is probably 350, I don't know, maybe 300. And when it's oiled up, it probably slides nice, but at the same time, it's hefty. And I think it would be nice to have a crank on here so you can move it, but we'll know more about that once we get to use it. If it was, maybe a little bit shorter and a little lighter, I would not even think about it. But I think with the riser block and everything, I think it's got some mass, and I think that would be a nice addition. We can always add that if we need it. Super easy. Fab up a bracket, interface with this, drill and tap some holes. Bob's your uncle. Pretty good to go. The other thing where I feel like this machine really needs some work is in the coolant management department. And a lot of this stuff we're gonna fix, guys, because you know me, I go hard and I like things a certain way. But starting with kind of the most obvious, this coolant setup here and this light bracket is kind of hokey. First off, this light we're ditching. No offense to this light, but honestly, like if you don't have light in your shop, this little light ain't gonna do much. If you're turning anything larger, it's just not high enough up. I don't even know how bright it is. We haven't turned it on, but it's kind of flimsy. Not a big deal. It's literally, it's an afterthought. We're gonna just eliminate it. But the bracket that this mounts to in the coolant is like a sheet metal bracket. It's floppy. The one that we did on the other Lion Lathe was freaking way overkill. So that's not worth comparing it to. But they could have easily done like a cast bracket. And also, not only is this like off-brand line lock, well, I guess it does have a name brand on it, but it feels cheap. It doesn't feel like the normal like line lock, the blue and orange stuff. But also, there's only one spout here. And if you're gonna run coolant seriously, you're gonna want like 2 different spouts. And I know that that's what Josh did on his. He just scrapped that immediately and ran a separate line with a T because sometimes you're gonna want one going in the back of your boring bar or your coolant for your tool holder, and then one drizzling on the work. So that we're gonna change, no big deal. And I knew that going into it, easy. The other thing is the coolant motor on this is hilariously small. I have a coolant motor over there on the fryer, and it's like 4 times the size. Now granted, that is a 3/4 horsepower, but I don't even know if this is an 1/8 horsepower, which is kind of common on these. It is a baby. It's like little tiny guy, and I get for some people, coolant may not be a big deal, and you just want a little bit of drizzle while you're machining, that's fine. But with what I'm planning to do, we're gonna run some big drills, we're gonna hog some metal, and we're gonna try to be efficient. That coolant pump, I'm not even gonna use it. We're gonna wire in and adjust the panel for an adequate size coolant pump so we can get good flow from more than one different location and do some work efficiently. In addition, and in same line with the coolant, I feel like the chip trays and the coolant management with the chips leaves some room to be desired. When they designed this machine, they put the cable tray in the front. On my Lion, obviously it didn't have one because it's super old, but I actually added my own cable tray and I put it in the back. And the reason that's nice is because it isn't in the front. And in order to accommodate that, you have this bar right here. And when you stand up on the machine, it's kind of at your shins. And I guess it's a little high right now, so it'd be a little bit lower. You're like your lower shin. But I feel like that's just not an oversight, but a design choice, where if they put it in the back of the machine, then you could get up a little closer and not be right on your shin. Now, I know why they did it. They did it because all the electronics are here, whereas on mine, the electronics actually come from the back. It didn't have a cable tray, but it came from the back and went through the actual carriage and top slide over to the front, whereas they kind of simplified and just brought it up the front because that's where all the electrical is, and I get it, but I would have probably put it in the back. And the reason why that kind of ties into the coolant is because of that. They also have this like front guard, and that means that you can't technically change out the chip trays from the front, which to me makes no sense at all. Now obviously if you have this machine away from the wall, you go around to the back, totally fine. And I'm not gonna jam this machine up against a wall like I normally do, which is good. But you operate the machine from the front, and I think, you know, as an ergonomic standpoint, to be able to come in the front, bend over, and to clean out the chip trays, you know, as you're standing, makes a lot of sense. And also, if you are in a tight shop, you can't put it against a wall because you got to have room for the chip tray to come in and out. Now, I think we're going to be fixing that because that kind of annoys me straight from the get-go, and I think it's easy to do. I already talked to Johnny, and I think it's just a matter of removing this. Now, this cable tray is going to be in the way, but I think what will happen is with this cover off, we can remove this chip tray from the front. And then if we need to remove this chip tray, I think if we take this and move it all the way down, there'll be just enough room for us to get it out, but I'm not sure. Well, that's pretty much it. The only other thing I had is minor, and again, I am nitpicking intentionally. We're trying to find things wrong. I'm sure we'll find some more stuff wrong and right as we get into it, but I'm just kind of giving you my initial thoughts. But this badge over here on the front, this badge is super boring. And I know that is just the lamest thing to say ever. But these plates are real nice. They're like 1/8" aluminum. They look really nice. But this huge cover has like nothing written on it. And I feel like that's a lost opportunity for some text or something so that it doesn't look so plain. Again, I know I'm nitpicking, and I am, but as someone who rebuilds machinery and tries to do things the most aesthetic way possible and maintain function, I think that could be a way to kind of make the machine look a little cooler or a little more interesting, because you just kind of have this big blank plate. Even on mine, the plate is smaller, so it doesn't look quite so out of proportion. But you know, that's small stuff. So overall, the machine, it's great. I'm really excited to get this machine running and to use it. And I'm really happy with how it looks. But I just wanted to give you my initial impressions, just looking the machine over without even getting it going and without even using it. Also, this chip tray, I think I'm gonna ditch it. It seems like a great idea in principle, but I kind of feel like it's gonna get in the way, just make things less convenient. I know Josh kept that chip tray near the chuck, which does seem like a huge pain in the butt, but he told me that it really helps keep the coolant from the chuck slinging, so I think I'm gonna keep that, but I do kind of like to have the raw chuck with no guard. But this one, I'm not as sold on this. I see why they do it, Honestly, I'm sure it's really nice standing here with this thing on. I'm just used to getting showered with metal chips, but also when you don't have one, you get up right next to the tool post, you do your work, especially with me filming. I usually mount my camera over here, so I don't know that this is gonna stay. But honestly, it's kind of nice, you know? So I don't know. That's, again, a lot of this stuff is not faults of the machine per se, just preferences, stuff that jumped out to me, and I wanted to let you guys know about it. We stayed up late last night reading the manual, and I came across these leveling pads. I saw these when I was unboxing everything, but certainly did not think they were leveling pads because of how weak and tiny they are. But the point here is they have a little notch cut out for a bolt. They want you to go ahead and bolt the machine down to the concrete. Because my concrete is not as stable in this shop, and because we might move this machine, we're not going to be bolting this machine down. However, I've had great success not bolting lathes down as long as they're stable and properly level. So with that out of the way, I decided to make my own leveling feet that would just provide a little bit more contact on the concrete, and more importantly, give me a little bit more height and distribute the load a little bit more evenly. So we're gonna be ditching these cast iron leveling pads. I didn't show you making these. They're super simple. I saw cut them. I put a little divot in there. That's pretty much it. Face both sides, chamfer them. So we got the machine where we want it. We're gonna go over to the machine, slide these under. I'm not gonna fully level the machine right now. We'll do that later with Daniel, but we'll just get it onto the pads and relatively close. We're gonna use the big toe jack to jack this up and slide our leveling feet in here. The other benefit of using these leveling pads is it gives us some room underneath the machine so we can get a toe jack in here. Sometimes the toes on these toe jacks are wider and thicker than the cutouts, so it just gives us a little bit extra clearance. We're gonna slide that out. I'm gonna slide these down. All right, we're coming down. Nice and slow. Make sure our bolt holes are lined up. And pretty typical here, we bottomed on our toe jack. All right, we had to space it up because we had a block in there on our toe jack. So now we can get these out and we can go down all the way. There she is. Let's go to the other side. All right, we're ready to come down. This is definitely an area of improvement on this lathe. It's not really a problem with the manufacturing, but when they painted this, they painted over all of the threaded holes. And so there's no room in here for a socket, which I think is a problem. The pacemaker, as an example, I can get in here with a ratchet, but on here you have to do an open-ended wrench. And in this case, because these threads are painted, you have to go one turn at a time. You can't spin them down by hand. And I did grab a socket with, you know, a tap, and we have this off the ground a fair amount, but you'd have to lift this lathe up probably another 4 or 5 inches so you get a tap in there to clean that out. So either if you're getting one of these, lift it in the air and clean all the threads out with a tap before you start. So just be advised that, you know, you're gonna spend 7 minutes turning a bolt 8 times. This toe jack I'm using is a little on the small side for this. Just gonna stop it right there. That stopped itself, of course, same problem, we're bottomed out. All right, we can come down the rest of the way. Just make sure the one in the back is in a good position. Sounds like my jack is slowly lowering, but the position is good. All right, that's it. We're gonna do the other 4 off camera. And I'll just get it rough leveled with a carpenter's level, and then we'll move on to the electrical. Now that we got the machine leveled, it's time to work on the electrical. Now previously we had the old Lion here, and I set it up with this 80 amp drop, which is 220 3-phase. Now these machines come from the factory 220 3-phase, but I opted to switch it to 440. By running it on a higher voltage, I have a lower amp draw, and honestly, a lot of the machines in my shop are 440/480, and if I ever move, I'd rather have all the machines set up for high voltage. It just makes running wire a little bit cheaper and easier, and so we opted to do for a 440 conversion. Now they took care of that free of charge, but that is a transformer change that they needed to do in the machine. But that left me needing a new run. So even though I have this current run right here that I'm not even using, I went ahead and did a new run of conduit, and that's what we have right here. So I ended up doing this double box because of the area in my shop. The bottom one I'm going to put an outlet on, and it will just give me another outlet for 440 for a welder, and then this top one we're going to take and come right out of there and into here and hardwire it. I ran the conduit ahead of time, but I really wanted to avoid junctions in the wires, which isn't a big deal, but I just wanted to minimize a chance for a connector to go bad or have a wire nut fail. So I didn't run the wire because I wanted to see where the machine was positioned. But now that the machine is in place, we're going to run a whip from here over to this box, and then we'll run our fish tape and figure out how much wire we need. Then we'll fish the wire and get it set up. I'm not going to show you fishing the wire. I'm by myself. It's going to suck and it's very tedious. But we have 6-gauge red wire, and we're going to run 3 wires for the 480, and then we'll run a wire for the neutral or the ground. So other than that, pretty straightforward. I think 6-gauge is a little on the larger side for what we need here, but I thought I'd be rather safe than sorry. And we're running this off a 40 amp breaker. So what I'm gonna do is I'll get all the wire and all the conduit whip set up, and then I'll meet you back at the panel so we can get this thing wired up. We got all them wires fished. It was a ton of work. We had multiple flex joints we had to go through. But we got everything wired in, and we're ready to get this bad boy started. So let's get this panel closed up and go around to the front of the machine. We also went around and just adjusted some settings on this DRO and got it turned on. Originally it was set up for the radius, and I like to do the diameter, and these axes were swapped. So we did that, and then I added a sleep timer, which is super nice. So basically this will go to sleep after a minute, and then it will pop back on when there's movement. So really excited to have this NMS 800. It's a really nice DRO, arguably not as nice as Steph knows, but a great piece here, and I'm very, very happy that that all came wired in and we're ready to put that to work. Let's go ahead and get this guy fired up for the first time. Right now we're running at 1250 RPM. That happened to me the very first time I started this. The cover is very sensitive on this machine. So just that little bit is gonna cancel out the motor and shut everything off. And it has to be in neutral when we go ahead and start it. So let's give it another whirl. And because this is clutched, we can ramp this up. And this is an aggressive RPM. Of course, you know me. Look at that thing. Thing is singing. Got oil flow in the sight. We have oil flow in the gearbox. And that's it. Our first startup. Go ahead and spin it down. And we'll power that down. Now we did end up having to make a modification to this shield, very, very minor. This shield was actually dragging on this. So basically what we did is I just ground down some of the area there, and I figured, you know, if you're on this and it sags a little bit, you know, we didn't want it bumping on this guy. So now even if you push down, it's not gonna hit it. But overall, we're gonna see if we keep this. Honestly, it's fairly annoying. If you go over to the lathe, I'm used to having access to the chuck, which is really nice. This kind of blocks the chuck wrench from actuating. Now the chuck wrench that they give you is shorter, so it's definitely doable, but I really like having that nice big chuck wrench. Gives us lots of leverage, but I can see that this is really useful in terms of not only safety, but more so the coolant. So we're gonna keep it and we're gonna see if we like it. But the thing that I just really don't like, aside from it being in the way here, is if this thing is not 100% over, it will not turn on the spindle. And more importantly, on this machine, I know Josh's might be a little bit different because he was telling me that he'll bump this to turn the machine off. On this machine, it's pretty violent. So if you start this and you bump it, it'll like cut the motor immediately and you'll hear the contactor struggling. And so I don't know if that's just because it's set up for 440 or what, but it's not like it cuts the motor and ramps down. It like stops it pretty quick, and you can tell that it is not, the electronics are not happy. So I don't want to get into the habit of bumping this because it really does try to stop it immediately. And for that reason, like even I learned that because I had this closed and I was messing around and I literally just nicked this a little bit and it stopped, got that huge loud noise that you heard initially, and it didn't sound good. So it's very sensitive, which is something that I'm not too excited about. So we'll see if that stays. But for now, that was the first startup. We're gonna move on to getting some material in there and going ahead and taking our first cut. We did install the tool post. We did a separate video on that, which you'll probably see after this, of getting that set up and the tooling we got. But for this video, we're gonna get some material, we're gonna take some test cuts, and then once we're done, we'll sort of wrap up with our final thoughts. All right, we got a piece of 1045, 7-inch, 6.5. See what I mean about this chuck key? Hits this. This chuck key will work in like a very specific range. This ain't gonna last, I can just tell you. If it's down here, it's not gonna work. Makes it difficult to use the machine, so we'll modify it. I'm sure we will. And the chuck key is so long that it hits the crane. Now obviously that's only gonna be applicable on short pieces, but still. See, I can't rotate this around with the chuck key in there. All right, now unfortunately the only insert I have for these bigger tool holders is this big boy. She's real big. So what we're gonna do is we're gonna we'll center drill, and then we'll take some cuts and see how she does. First chips. Zero my DRO. All right, 1/16 of an inch. This insert is not the best insert for light cuts. I'm just gonna say that from the beginning. You can see it's stringing pretty bad. That's fine. The first chip is the worst chip. We're just gonna get it faced and center drill it so we can take some real cuts. All right, we switched tool holders. Turns out that this tool holder is too big. I think this tool post is, even though it's within range on this size of a lathe, I think it's honestly a little on the big side. So when you put the proper size tool holder in this and you drop it all the way down, it's still like a 1/4 inch tall. So if we use a smaller tool holder, it's gonna be fine. But ultimately, I think this tool post is maybe a little large. So obviously we're not gonna buy another one, but if we use these full size 1.5 inch shank, I think we're gonna machine off like a 1/4 inch off the bottom, and I think we'll end up being fine. So we switched over to a smaller 3/4 by 3/4 tool holder, which is a little small, but we'll go ahead and face this. I just got it kicked at an angle for clearance and see if this is any better. Chipping much better. The insert is not too oversized. The other insert is pretty much a balls to the wall insert. 3, 4, 5, 6, 700 thousandths depth of cut, but it kind of sucks on these little cuts. And my feed red is set way too low, of course. And even still, looks like I need to go lower. Man, the amount of effort that takes to push is crazy. All right, here we go. We got our tool modified. We got our center drill in, and this will be the first transverse cut on the lathe. I think we're at 9 thousandths per rev. Okay, that feed rate looks good. The depth is not. All right, tailstock loosened up. Let's take a deeper depth of cut. Not happy. All right, we've slowed the RPM down. Now I know this is an aggressive cut, I'm aware of that. But hey, it's a big machine. Let's see what we got. Day one, huh? That's how we roll around here. All right, well, we spun the workpiece. Let's get that insert changed out. I think we need more torque on the workpiece. And maybe we take a little bit of a lighter cut. What do you say? All right, take two. Yeah, that was a little bit aggressive. Got our insert changed. Again, this insert, it really works well when you push it, but we're pushing it quite a bit here. This is the maximum depth of cut of this insert. And I did not do that intentionally. I just kind of used my eye. I measured this with a caliper. This is 330 thousandths. If you look this up in the catalog, it says it's good up to 315 in feed. So that's 600 thousandths, 650 thousandths off the diameter. And it's interrupted. Probably a little much to start with. You know me, I always like to push things. Let's just back up, start out gingerly, work our way up. So we were taking 600, so let's do 100 ain't gonna do nothing on this insert. But let's do, no, let's do 150 to start. That should be easy mode. There you go, you know why? Because I had the cover open. I think we're gonna get rid of this cover, and the reason for that is like on pieces like this that are small, I like to stand here. And this thing is just in the way between the camera and this huge tool post. There's just not a lot of room around here. But for the video, let's keep it rolling. All right, no problem at all. Now, honestly, I think this can do it. I think our chuck was a little loose. It slid a little bit, and I think I needed to retighten it. So we're gonna get there, because I'm crazy. This is about 500-ish when it gets into that next one. There it is. Now we're doing work. That was happy, all right? I can't tell. I think the machine was fine with it, but hey, I'm crazy. So let's finish that cut. I know this insert will do it. It's not a matter of that. Got my hand on the feet if we need it. Okay, it was doing it. I feel like the motor was bogging just a little bit. I think let's step down the RPM. We were running that at 200. Let's go down to 160. Depth of cut is, looks like 600 on the total. 640, is that what I said? So that's like 310. All right, let's see what she's got. Just gonna make sure my center is tight. See if she's gonna run happy at 600. All right, couple things. She's doing it. I don't know that she's happy about it. I don't know that I noticed that the motor was bogging, just didn't seem optimized, especially with the chips kind of shooting out the front, not having a chance to fully form. Yeah, I wanted to know if we could run this tool holder. I think we can. Let's step it up to 250. Let's go back to 500, where it seems to be happy, and let's see if we can machine a decent amount more. Let's touch off and take 500. I think it's gonna be happy. We're running a little faster. Some would say too fast. All right, so we touch off. Just do a little 500 thousandths off the diameter. Should be well optimized here. There we go. That's what we're talking about all day long. Surface finish good. Load is good. That thing is getting to work and I like it. All right, I'm happy with that. No need to waste this entire billet. Surface finish, pretty dang good for roughing. 500 thousandths total, 250 a side. Feed rate, pretty aggressive, or moderately aggressive. What was I at? 12 thousandths. So really this thing wants to be run from like 10 to 20. 20 is too much. The machine doesn't have enough grunt to do it. But this is pretty optimized for this insert based on surface finish, the load of the lathe, and the chip formation that I'm getting, and the sound of how everything machines. So this is pretty good. I wouldn't call it the limit of the machine, but this is kind of where I'd want to run it comfortably if I'm working hard, right? I wouldn't want to run much harder than this if you're going to machine for 2 hours straight. And even this, it's a little iffy. Maybe I dial back to 400, but it can do this and it doesn't seem sketchy, so that's good. Overall, pretty happy with that. Yeah, that's our first test cut. We took our test cuts and everything went fairly well. I'm fairly impressed with the machine, and typical Kyle style, we jump right in there, take some beefy cuts, and basically spin the part in the chuck. And what can I say? I like to push the equipment, see what it can do. But I want to round out the video with some comparisons between this and the pacemaker and the old Lion. Now, caveat, these are my initial impressions. So what we need to do is we need to spend the time, 6 months with this machine, and revisit it and see how I feel then, because how I feel about the pacemaker is established over time. And just like with any machine, you gotta work with the machine, figure out what things are actually gonna bother you, what things are not, what things you like, what things you don't. You change things and you get to the machine where you want it. And right now the machine is kind of as it is, no modifications, initial impressions. So from my perspective, the machine is only going to get better from here as we know how to use it more and as we know how to modify it and change the things that are convenient and things that I like. So comparison wise, the first thing is I noticed that on the old Lion Lathe, the motor drive belt pulley has 6 slots or 6 belts. On the pacemaker, it has 5 belts, and on this machine, it has 4 belts. To me, that was a little surprising considering that the horsepower of the pacemaker is only 10, and for me, I've slipped those belts before on that machine. Now, these belts do run tighter, and I have a hard time believing that I'm actually going to slip them, but it is a little surprising that an older machine with lower horsepower has less belts than a newer machine. Talked to Josh, he said it won't be an issue. I doubt it is, but I thought I would just kind of draw that comparison because I did find it interesting. Now, as far as the actual apron, this apron is a little smaller than the old Lion. Of course, it's a smaller lathe, and a little shorter than the pacemaker. And of course, the pacemaker's apron has been designed from the smallest, which I have, all the way up to the 36-inch. The apron is the same size. So it's not really a fair comparison, but I want to just kind of draw the correlations there. In terms of the effort to move the carriage is actually pretty similar between this and the old Lion. The carriage moves a little easier on this compared to the pacemaker, but I wouldn't consider it easy by any stretch of the imagination. It definitely takes some effort, and more effort than I expected. I think I have a little more control over this carriage using the hand wheel compared to the pacemaker, but this doesn't feel like a lot of other machines that I've run. It feels maybe more plasticky, or I don't know. It's a little bit unusual. The old one doesn't feel like that, and the pacemaker doesn't feel like that. Maybe that'll kind of loosen itself up. It's definitely tight, which is good. But yeah, that's my thought on that. As far as the top slide on the Lion, chef's kiss, perfect. And you know why? It's because we rebuilt it, scraped it, turkited it. It's bigger, it's smooth, it's beautiful. All right, so that's kind of not fair. This cross slide is way easier to move, or easier, I shouldn't say way easier, than the pacemaker, so that's good, and it's kind of bigger. And that's one thing that's really good for this machine is on the pacemaker, the top slide is short. Now it has a cover on the back, but this top slide goes the whole distance. And it's like that on my old Lion. I like that because that helps distribute the load over the entire surface of the apron, and that's nice, that's heavy duty. So this top slide, bigger and smoother than the pacemaker. The motors, so compared to all 3 machines, this machine is the loudest. I don't know if you can tell by watching the videos. The old Lion, a lot smoother, a lot quieter than this, and that's before we rebuilt the motor. We rebuilt the motor, I'm sure it's even quieter. The pacemaker runs smoother and also quieter. We also rebuilt that motor. Both of those motors are very old. That one on the old Lion is, I think, 30 years old, or no, 40, it's from 83. It's about 40 years old. And the one on the pacemaker, it's from the 70s, so maybe 50 years old. So that probably has a little bit more to do with the quality of the motors at that time. This motor sounds kind of noisy. It's not concerning, but I wouldn't consider it quiet. I would say ergonomically, the ergonomics between this and the old Lion are pretty similar. I would say that the gear selector on the newer Lion is less intuitive than the old Lion. Now it still does have a double lever, similar concept, but I feel like the gears shifted a little smoother in the older machine. Could be because it's older and a little more worn in. But the actual ergonomics of this compared to the American, no competition. The American blows this away. It has nothing to do with Lion, nothing negative towards Lion. This was probably engineered by someone in Europe, and you know how we are in America here. We're a little bit, USA, straightforward, straight shooters, and we all think similarly. So that pacemaker lathe, you walk up to it, I could tell someone, hey, go put it in 55 RPM, if they knew nothing about machinery, they could get that machine in 55 RPM. You walk up to it, there's a plate, it says the RPM, and you move one lever, that's it. This machine, no joke, I spent 2 hours trying to figure out how to get it into each speed and how to understand the threading chart. I am fully aware of how to do that, and that will never become a problem in the future because I'm familiar with it, but it's not necessarily intuitive. There's 3 rings here on this shift lever, and basically you can access every other speed of that ring with one direction, with this straight up and down as you rotate the outer ring, and with this kind of cocked 30 or 45 degrees, you can get every other, and that to me seems weird. I don't know, there's a reason why they did it that way from an engineering standpoint, but it's not intuitive. This lower knob is blue, red, green. It's easy, blue, red, green. The upper knob, I don't know why they did it that way. I'm sure there's a reason, probably having to do with the gear reduction ratio in the back and having all of those speeds and feeds without a change gear, which is good. But as a result, I would say the speed shifting on this machine is definitely slower and less intuitive than both that and then the older one. But the pacemaker is way better. Also, I would say that changing the speeds in the gearbox is definitely a little bit slower, but I think that has more to do with the fact that this gearbox isn't worn in and the detents are just not as certain. It takes a minute to kind of fight with that. So I'm fairly certain that when we warm this machine up and wear it in, that will kind of get a little better. But that is, you know, just kind of off the hop what jumps out at me compared to the American. You want it in C, boom. C with this, C and D is not too bad, but the 1 through 8, you know, it takes a minute to kind of fiddle it around. Not a major deal. Everything else is pretty much what you would expect in terms of power. I didn't take any test cuts on that big boy Lion, but it's smooth, it's got a massive chuck, and it has tons of power. That machine is gonna rip through. We'll take a 1-inch depth of cut or we'll fail, and it'll do it. This machine, although it only has like 5 or 7 more horsepower, you can tell that it does not have the power of that bigger Lion Lathe, which is totally fine. This machine also has more power than the pacemaker, but not as much as you would think. Now this thing is 15 horsepower and that thing is 10 horsepower, but to be honest, it kind of seems like this has a couple extra ponies, but nothing crazy, right? So when I was taking those big 500-600 thousandths depth of cut on this machine, I was also taking those same cuts on the pacemaker. Now this machine wasn't as much laboring, but it wasn't just breezing through like I know that bigger Lion will. And those are some healthy cuts, but still just running bigger and smaller machines. This machine has more power, but not absorbently more power. And it definitely doesn't feel like 50% more power. But you know how those old motors are. A lot of times they were sort of underrated. Finally, I just want to say that I am very, very excited for this machine. And I'm very, very thankful for Johnny, who helped me set up the purchase of this machine and worked with me. This machine, compared to other machines on the market today, is high quality. I know we went through and talked about some of the things that I didn't like and things that I'm going to change. And keep in mind, I am very particular about my machines. And at the end of the day, it is nearly impossible to do a direct comparison between this and an older machine like a Monarch or a pacemaker. It'd just not be possible to build a machine like this to the same standards as those other machines, or the machine would cost $150,000. When those machines were produced, it was a different time in history and a time without real engineering. So a lot of times they over-engineered things and they knew the machines would be set up in production day in, day out. I guarantee you 90% of the units that are sold here are not in production. They're going to be used by job shops like us. So these items are just less critical. So the demand on the market for what was at the time on the pacemakers and the LeBlancs and the Monarchs just isn't the same as it is today. And that's why they've made the decisions that they have with these style of machines. And I personally have ran a brand new 2023 Nuth version of this, same price, but was way, way worse quality. And from far away, they would look very similar. But it has to come down to the build quality that Lion, as the distributor, specs when they purchase the machine and they build these out. And they do take the time to make sure these are built to a higher standard and have better features than similarly priced machines on the market. And these are made in Europe, and Knuth being made in Taiwan, and Sharp in Taiwan, and a lot of these other Summit Taiwan and some Europe. There is a difference. So with all that said, my initial thoughts of this machine are that it's going to be an excellent machine for our business. I'm really excited to utilize this machine, but we do need to do a fair amount of things to this machine to bring it to Kyle's standards, which are very high, right? And a lot of that is revolving around the coolant and chip collection system. And I won't beat a dead horse, but what we need to do is we need to address that if we're going to be using this for heavy use cases. I was just talking to my wife. We were making a first cut and I was showing it with her, and I was showing her how the chip pan is already kind of full just taking those cuts. And you know, that's nothing. But the point is that chip pan is like 6 inches from the bottom of the casting. So if we're gonna be doing real work on this machine, that chip pan is gonna fill up right away. Now again, if you're just doing stuff here and there, job shop stuff, may not be a big deal. But I want to really burn through some material on this thing and not be fighting small chip trays or coolant pumps or stuff like that. So for now, we're probably going to run it as it is as long as we can, but we are going to come in here and address some of those things that annoy me so we can make this machine even better. So with that being said, I hope you guys enjoyed this brand new machine day. I'm curious to hear your thoughts below in the comments, and watch out because we're going to be doing a lot more work with this machine. We'll see you in the next one.